All right, so for today's topic, we're going to be talking about how to find horizontal and oblique asymptotes given a rational polynomial expression. So I will write this in the abstract, but as I give you each of the rules, I'll give an example as well. So in the abstract, here's what we have. Say you have any polynomial expression, p of x, and it's equal to a times x to the n plus or minus blah, 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 over bx to the m plus or minus blah, blah, blah. So the reason I'm doing plus or minus blah, blah, blah is that for all the rules, all that's going to matter is the largest degree term and its coefficient, both for the numerator and denominator. So you always have to make sure to pick the largest degree. And we'll see what that means with some of these properties. So property 1. What if the exponent n on top in the numerator is less than the exponent m in the denominator? Well, this one's pretty straightforward. Then your horizontal asymptote is y equals 0. An example of that would be, say you had something like 3x to the 17 plus 2x minus 1, and then in the bottom we had 4x to the 18 plus 1. I don't care about all these other terms. All I care about is the highest powered terms. So the highest power on top is 17, and the highest power on the bottom is 18. 17 is less than 18. So my horizontal asymptote is y equals 0. Done. Just as a quick refresher, what a horizontal asymptote is say you had some function that looked like this. The horizontal asymptote is the horizontal line that it can never cross. So perhaps we'd have one right here. So the function may do all kinds of crazy stuff, go up and down and what have you, but it probably will not cross the horizontal asymptote. I say probably because there are a few functions which are weird and they might cross once or something. But in the general behavior of the graph, like perhaps we have something like this as well, where it is crossing through the horizontal asymptote. But what happens is it starts to peter off and be around that horizontal asymptote. This is really rare though. So usually a horizontal asymptote is just a line you don't touch. But the more general thing is it's something that the graph sort of doesn't touch either from above or below. It wiggles, and that's like its top value. You could also have an oblique asymptote, which is where if you had a function doing something like this is a different function, then the oblique asymptote would be one that's slanted like this. The rules I'm going to show you are going to show you both how to get horizontal and oblique asymptotes. So one oblique horizontal asymptote that's flat like this is y equals 0, and that's always going to happen when your degree in the numerator is less than your degree in the denominator. Now, the second property is what if the degree in the numerator matches? What if n equals m? Well then, your horizontal asymptote is going to be equal to a over b. Well, a or b are the coefficients on these terms. So let me use this similar example here. Let me say 3x to the 17th plus 2x minus 1 over 4x to the 17th plus 1. Well, 17 equals 17, and those are my highest degree terms. So my horizontal asymptote would be y equals 3 over 4. So the leading coefficients. If they were reducible, say this was 2 over 4, I would reduce it and write it as 1/2. So that's the second property. If the exponents match, your horizontal asymptote is just equal to the ratio of the coefficients, just numerator divided by denominator. Now, rule number 3 is very specific. It's if your degree on top is exactly 1 more than the degree on the bottom. Then, no one likes this one, do long division. Your quotient, whatever you get when you do that, is your oblique asymptote. So let's see an example for that. Let's see. That looks like it'd be a pain to do long division. So instead, I'm just going to do x cubed plus 2x minus 1 over x squared minus x plus 1, something like this. So now notice, ooh, I should have some squares. Let's make that 2x squared minus x plus 1. There we go. So now look, your highest degree term on top is 3. Your highest degree exponent on the bottom is 2. 3 is exactly 1 more than 2. So I'm going to do long division. I'm going to have x squared minus x plus 1, x cubed plus 2x squared minus x plus 1. I'm just going to do this. So x cubed divided by x squared is x. Multiply it back down. Minus x squared plus x. Subtract that. Gone. 2 plus 1 is 3. Negative minus, so that's minus 2x plus 1. Now I'll divide again. So 3x squared divided by x squared is just 3. Gone. X minus 2. Now really I could have stopped there, because notice if I try to do x divided by x squared, I'm going to get 1 over x. That's always when you stop with polynomial long division. Now, if you're not too sure about the long division part of this, don't worry. We'll go study that in a separate video. But what matters is if you do long division, you get this right here, that x plus 3. That is going to be your oblique asymptote. So y equals x plus 3 would be the oblique asymptote for this example right here. So again, number 3 is if your degree on top is exactly 1 more than the degree on the bottom, you'll just do long division, and then what you get is going to be your oblique asymptote. Okay? So there's one more rule. If n is bigger than m plus 1, so say instead of x cubed here, this was x to the 4th, and the bottom was still x squared, 4 is not exactly 1 more than 2. It's 2 more than 2. Well, no horizontal asymptote and no oblique asymptote. So rule 4 is pretty nice. Basically, rule 4 just says if rules 1, 2, and 3 don't apply, then you do not have a horizontal or an oblique asymptote. So just as a quick review, rule 1 is if the degree on top is less than the degree on the bottom, y equals 0 is your horizontal asymptote. Rule 2 is if the degree on top matches the degree on the bottom, then your horizontal asymptote is the ratio of the coefficients, right? The number on the first term divided by the number on the bottom's first term. And then rule 3 is if your degree on top is 1 more than the degree on the bottom, you do long division, and whatever you get as your answer, your quotient, y equals that is your oblique asymptote. And I just want to point out that n is either less than m, or it's equal to m, or it's equal to m plus 1, or it's bigger than m plus 1. These rules cannot happen at the same time. You can't have a case where n is both less than m and also exactly 1 bigger than m. That can't happen. Well, why is that important? Well, that means that if you have a horizontal asymptote from either one of these rules, then you don't have an oblique asymptote. Likewise, if you have an oblique asymptote, you don't have a horizontal asymptote because the rules that give you those are mutually exclusive. They don't overlap. So that's the main, these are the rules for finding horizontal and oblique asymptotes, and they're used for polynomials of this form. Always make sure you grab the highest degree term on top, even if it's not written first. Be careful about that. And so if you just use these, you will get your horizontal or your oblique asymptotes, or you'll be able to confidently say that there isn't one. And that is this topic.